Awesome.
Yeah.
So thanks. Good morning, everyone. We are into the third day of this wonderful conference, and we are joined here today by Gil Forsyth. He'll be talking about Ibis, and we are excited to have you here. So let's get started.
Thank you very much. Good morning, everyone. Thank you for coming. I'm Gil. I'll say that a couple times, I think. This is a talk about Ibis and interfaces. Just a little bit about me. My name is Gil Forsyth. I'm currently not beholden to any corporate interests, so things are about to get real. You can find me on GitHub or Mastodon. This is our mascot, Patrick, for the project. This is a 100% portable Python dataframe library. Things I always forget to do, I'm just going to do at the beginning of the talk. So if you'd like a link to these slides, here's a link to these slides. And I have stickers, and I never say that at the end. So I have stickers. If you'd like stickers, please remind me at the end. You can come get stickers. I'll stand here for a few more moments. You can also ask me for the link later too, but yeah, since we got it up. Okay, cool. Okay, so what is Ibis? Ibis is an open source pure Python library, and it is a data frame interface. And what do I mean by interface? Well, if we're going to talk about data frame interfaces, we should probably also talk about data frames. If we're going to talk about data frames, we should probably talk about data. So what is data? Tabular data, like a spreadsheet. Any self-respecting data frame interface is going to let you sort of describe some set of actions you can perform on this data, right? And you have columns, and they hopefully have some types, and then they have values in the rows. Got it, cool. And then you want to be able to query tabular data. And so here are three common data frame interfaces you might run across when you're using Python, right? So you've got pandas. If you wanted to say, remove all of the rows where someone's height is less than 100 or less than or equal to 100, and then sort the remaining values by what is in the mass column, right? And this is pretty straightforward. Or you could write it in polars, right? It's doing the same thing. You could write it in PySpark. It's doing the same thing. And these are all slightly different, right? But they're sort of mutually intelligible to our eyes. You can look at any of these. Even if you're not familiar with how to use these particular projects, you can kind of see what it's doing, yeah? And in fact, if you execute all of those, you will get the same answer. So it sort of doesn't matter which one of them you use for this particular query. The mechanism, though, of the execution is really different, right? So pandas is using like NumPy and PyArrow to do this. Polar is using Rust stuff. PySpark is in the JVM. But the thing to think here is that these are interfaces when I'm typing this. The interface isn't running the query. The engine is running the query. That's a different thing. So in PyData land, we have this idea of like interfaces and compute engines being very tightly coupled, but they don't have to be, right? So you have the interfaces again, and the interface, you have pandas interface, it executes on the pandas engine. You have the polars interface, it executes on the polars engine. You have the PySpark interface, it executes on the Spark engine, right? And there's mostly this one-to-one equivalence, but there are projects that are starting to kind of break away from this pattern. So for instance, there's the PySpark.pandas project. That would be to use the pandas interface, but execute on the Spark engine, right? And all I'm saying here is that these things don't need to be tightly coupled. There are ways to use interfaces with different engines. Alternatively, you can use Ibis, and it'll just work on all these things, right? And again, I would suggest that even if you don't know Ibis, that this is mutually intelligible to all of us. It's doing the same thing that all of those previous three examples were doing. So what is Ibis? Ibis provides a Pythonic data frame interface to 20 plus engines. We are only an interface, right? We leave the engine part up to all those amazing projects that are already out there. We don't need to write our own engine. And we let you build a query, but we're not the engine. We hand that query to the engine of your choice, or to the engine that you have access to at your day job, or the engine that has access to the data you need. And on that last point, sort of like where the data are, is illustrative, I think, of one of the ways that Ibis can be really, really helpful. So imagine that you have some remote engine, you have some local, right? You have data on, in this case, Snowflake, but this is just representative, and you want to execute a query against it. So Ibis has a deferred execution model. And what that means is you build up an expression or a query step by step, but nothing gets executed until you're ready to run it. And this can be really, really nice when your data are somewhere else. So in this case, for instance, we might connect to that engine, just ask, hey, do you have a table called ratings? And what we get back from the engine is only the schema of the table, right? A description of the column names and the data types. From there, on your kind of client side here, you can build up this deferred expression, you can validate it, compile it to whatever you need to compile it to, more on that later, and you get a query out of it. Then we send the query to the actual engine, the engine executes the query, and then we pull back the results. So a couple of things about this that can be very nice. One, the thing on the right is probably bigger and faster than the thing on the left, right? And the thing on the left could be like a second-gen Raspberry Pi, it doesn't really matter, right? As long as you kind of have like a reasonably sized network pipe. And also, the engine on the right is almost certainly much closer to where the data are and has much bigger pipes attached to it, right? Like your connection to S3 is slower than some massive VMs, like huge gigabit or many 10 gigabit line that they have. So the execution happens at the speed of the back end, not at the speed of your local. Alternatively, sort of what the pattern has been in PyData space for a while would be you have this remote engine, you connect to it in the same way, and you say, hey, do you have a table called ratings? And then you slurp up that entire table, right? You download the entire thing. Then you load that data into memory on your machine, you parse the types, you perform your analysis, and then you get your result. This is fine for small stuff, and if your network connection is fast. But there's a couple of things where this can really not serve you well. Like one, if you're out of memory, you're out of luck, like that just stops working. And this doesn't scale very well. But I think the bigger problem here is that it's treating that remote engine like a data store. And while it is storing data, it can do many more things. You're sort of leaving a bunch of performance on the table. And you sort of want to be able to use those engines to their fullest capabilities. And I want to say note here today, I am not saying don't use pandas or polars. Right? What I'm saying is that in this scenario, there are 3 engines on the board and only one of them has the data. So you might want to use that one. So let's see what that would look like. And now I will attempt to type while looking behind me. Is this big enough for everyone? Yep. Yep, great. Okay, so I'm going to import Ibis. Oh, this is harder than I thought it was going to be. And I'm going to connect to Snowflake. Okay, great. So I have a Snowflake connection now. This is I'm doing just for the record. I'm doing a live demo that involves Wi-Fi at a conference. We'll see if this was a wise choice. I'm going to list the tables that are there, right? And there are 2 tables. And so what just happened? Like there was a brief bit of network traffic because I had to get authenticated against Snowflake, right? And now there's been a brief bit of network traffic as I said, what are the tables you have? So far, though, that's the only kind of exchange we've had. And now I'm going to pull those tables out because I kind of want to work with them a little bit. So I'll say, get that basics table, and I will get that ratings table. And here, there's also been a very little bit of network traffic, but I haven't downloaded the data. I've downloaded the schema. So I have, for instance, here are these columns in basics. This is some IMDb movie data. So here's the basics table, which has like the movie titles and what kind of movie it is, and whether it's an adult film and like the year it was, like they started making it or something like that. And then I have a ratings table. Okay? And that has the ratings, which has this, this primary key, the average rating, and the number of votes that that particular key has. And so let's say I want to put together like a top 10 list of, IMDb top 10. Right? So I might start by saying, okay, I've got this basics table. I happen to know that all of the columns in this are in camel case, and I hate camel case, so I'm going to rename them to snake case tables, snake case names. And then I got to do a little bit of data massaging and filtering here, right? So I want the basics. Actually, maybe I'll save this into a variable. I'll say basics. Well, okay, we've kind of let the cat out of the bag here, haven't we? But and we want the title type to be, I'll use a different quotation mark to hide this, okay, to be movie, right? And we're going to keep this family friendly, so we'll say is adult should be 0. I know that that's an integer. Okay, so that would sort of give us only the movies, right? but we also need to then join those ratings in. So we might join that ratings table in, say ratings, we're going to join that on the tconst column, and then what we want to do is do a little more massaging. We want to say, we'll filter out anything where the number of votes is, number of votes? Yeah. We'll say greater than 100,000, because we don't want to include like a movie that just has like 2 votes at like 10 and say that that's better than Shawshank Redemption. So that should give us that, and then we just need to give ourselves a kind of a descending order, right? So we'll say we'll order by, and the thing we want to order by here is going to be the average rating. We want that in descending order because we want the bigger ratings at the top, yeah? And then we probably actually don't need all of the columns in both of those tables, so we might just select out, say, what would it be, like basics.primary title, and then we'll grab ratings.average rating. That seems good. And then we'll say limit 10. So we only need the top 10, right? Okay, great. I still haven't sent anything to Snowflake, right? I have an expression now. And I can choose to execute it, and I will. I'll show it to you. So I could execute this, and I can say, Snowflake, please execute this query, give me back the data, and then Ibis will coerce it, in this case, into a Polar's data frame, because maybe that's the format I want to have it on my laptop. I can do that. Hey, it worked. Sweet. And that means the Shawshank Redemption at the top. That definitely makes sense. And then that looks pretty much right. I can run the same query again. Get this up to the top, but I could, if I wanted it, back as pandas instead, I can do that. You get a pandas data frame back instead, it's the same data. The query now, I should say, is like nice and hot on Snowflake. They're just going to give it to me right away. Or maybe you have some kind of streaming thing you want. You want to like do it as a PyData record batch reader. That's just going to give you back something that you can't see, but you can kind of get the data back in whatever format you want. But like, what's this expert thing? Yeah, that is this deferred expression, right? And it sort of has we have our own intermediate representation here. But what are any queries? They're a collection of like filters and mutations and sorts and projections and limits. We don't always call them that. Those are sort of that's the terminology of Ibis and kind of relational algebra. But you can do this thing, and one of the cool things about this is that you can, for instance, say, like, how are we actually executing this thing? Well, we're compiling it to SQL, right? So that's because like Snowflake speaks SQL. That's how you work with Snowflake, right? I'm not a huge fan of SQL, but it is available as an interface. But we have this deferred data frame interface that lets you operate on SQL engines, but you can write things in a kind of chaining Python-y way. In this particular case, I'll tell you, this is Snowflake SQL. Why is it Snowflake SQL? It's because, well, we're working with Snowflake, but we can handle other cases. I will switch back now to here. Sorry, and the last thing I just want to say here, just to reiterate, the only things we downloaded were about 10 rows of data, right? I did it twice, because first I asked for pandas and then as polars, and so like maybe 20 rows total. But like conference Wi-Fi, like live demo, like the one thing you don't want to do is start that by downloading an 800 megabyte Parquet file. Like, yes, you can definitely run that on your laptop. That is not the problem. The problem is that it's not on my laptop right now. So that would be a bad way to start this. You'd just be watching, we'd have a download counter going, it would be sad. Did that. Okay. I also want to say at this point, it is okay to use the tools that you know, and if the tools that you are using meet your needs and you like them, they are good tools. Do not let me or anybody else tell you otherwise, all right? Just ignore the hype cycles, everything's gonna be fine. Also, I like all the tools that I'm talking about here. And in fact, you can use all the tools here with Ibis, because Ibis is an interface, right? So this is not a question of should I use Ibis or, it's a question of can I use Ibis and, right? The whole idea of liking your tools is sort of this idea of the manifestation of this fact that like the interface is actually very important, right? And the engine is important, like you need things to be fast sometimes, you've got constraints on the work you're trying to do, but the interface is important. And we want to have good interfaces and we want to have good performance, but do not let the engine dictate the interface, right? If your data are in Databricks, it's probably a good idea to use Spark as your engine. If your data are in Snowflake, it's probably a good idea to use Snowflake as your engine, but that doesn't mean that you have to use their interfaces, right? Now, speaking of interfaces, there is another interface. The elephantine duck in the room. There's the universal interface for working with tabular data, right? We all know what's coming here. SQL, the ubiquitous interface. SQL, as we all know, comes in buckets. But this slide is a complete lie, actually, right? Because I'm saying, oh yeah, use SQL and you can use DuckDB or Postgres or BigQuery or Snowflake or all those other logos down there. But that's not true. You don't actually use SQL to query these engines. You use DuckDB SQL to query DuckDB. You use Postgres SQL to query Postgres, BigQuery SQL to BigQuery, Snowflake SQL to query Snowflake, and a lot of SQL to query a lot of other things. Right? And I should note here, tip of the hat to DuckDB, which tries very hard to remain drop-in compatible with Postgres, but drop-in compatibility is another pitfall of lots of projects. And also, look, there are reasons why there are dialects and differing behavior between engines, right? And that's because there are questions that don't have single answers, and people make decisions because you have to make decisions. So let's ask some questions. Does a week start on Sunday or Monday? You have opinions. Are days of the week 0 indexed or 1 indexed? These two questions interact in horrible ways, by the way. Like these two especially bad, right? Do nulls sort ascending or descending or always first or always last? Given a function to compute the log of x to some base b, is the function signature log b comma x or log x comma b? I have opinions, right? But there's no single answer to any of these things. And so what that means is that, while a document exists called the SQL standard that none of us can afford anyway, it isn't standard, right? So here is the same query. This is a query that is trying to get a count of the number of characters that have Darth in their name from like a small data set of Star Wars characters, right? And this is in, let's see, BigQuery, Postgres, DuckDB, and MS SQL dialects, I believe. I've forgotten. Which is an exercise to the reader. Have fun. I'll note some things here, right? Quoting behavior is different. Function names are different. The data type names are different. Whether bools even exist as a data type are different. Fun fact also, some databases use IFF to mean if and only if, and some use IIF to mean if and only if. Have fun. And what I'd like to tell you is just that Ibis will do this for you. You don't have to do this. Please don't do this. This is terrible, right? Yes, there are tools which people we'll template it. Templates will help us. I did that. Here's the template for that query. It seems very maintainable. I think we should put this in prod right away. Ibis will do this for you. Here's how you write this query in Ibis, by the way. You say Star Wars, that's the table. Give me the name column, lower it. Does it contain Darth? Sum it, please, right? And we will run this on DuckDB or Postgres or BigQuery or Snowflake or all the other things that I'm not going to say right now, but I'll say them all later, okay? And I just think this looks cleaner, right? Also, look, it's a Python conference, we're Python people, you want to write Python, yeah? This also comes with tab completion, and it's in your REPL. Like, those are nice things. Also just point out, when you are writing these things, I like to work this way, I like to chain. I have this table, I want the name column. Okay, now what I want to lowercase it. Does it have Darth in it? Yeah, it does. Can I sum that? Sweet, done. That's it. If you're writing this in SQL, even if you know where you're going, it's not great. Select name from Star Wars. Okay, I'm good here. Okay, but I want to lower the name, parens, and then does it contain it? Okay, go back to the front, and then say, does it contain Darth? Single quotes, double quotes, single quotes, can't remember, it should be single quotes. Yeah, okay, go back to the front, I'm gonna need to sum that now. Okay, close the parentheses on the other side. Oh crap, actually I just remembered you can't sum a Boolean in SQL, so I'm gonna need to cast that to an integer, so I better put the cast in there. Do you do a comma with the cast, or do you say as? It's not a comma, it's as. Did I count the parentheses right? I don't remember, and also don't forget the semicolon at the end, right? And so here's the thing, SQL is really difficult at first, but once you use it regularly and learn more about it, it's even worse. Okay? And then there's other questions, like what comes after the query, right? How do you write the query results to a Parquet file? What connector library should you be using? How do you pull query results and put them into an Arrow record batch reader because you want to stream them somewhere else? How do you make whatever engine you are using or that you have to use, because of job or data, work with the rest of the PyData ecosystem? I was at a previous job, and we had these Parquet files in S3 and a bunch of additional data in Snowflake, and we were training models using Dask XGBoost on GPUs, right? Now the SQL being executed in that for little joins was less than 1% of the total code volume, right? It was just, but we needed the data. It was this little thing we were doing, and there was so much glue code for like setting up Snowflake stages and moving files around and exporting data and making the schemas align, and like, you can do that yourself. I have done it myself. I don't recommend it. Like, it's not fun. Ibis already knows how to do those things, and it will help you with them. You're still gonna have to do work. You're still gonna have to look at the schemas. It's not a magic bullet, but like figuring out how to load a Parquet file into Postgres, we got you. Like, just let us do this, let us help you. And I should say too, I mean, I'm harshing on SQL, I'll continue to do that. But why would I ever use SQL? SQL can be fine, right? It's very stable, right? It's like, talk about backwards compatibility, like it's highly backwards compatible. It's the lingua franca of the data world. It is, you know, everything speaks SQL. You might know SQL, your coworkers might know SQL, and you might need or want to use a SQL database. They are very, very fast, right? Especially, you know, the column stores. And like maybe you want to try DuckDB, you're hearing a lot about DuckDB, but like it's already hard to switch tools, and now you also have to learn a second language. I don't know if I want to, but like, no, seriously, don't let the engine dictate the interface, okay? If you want to try DuckDB, don't get blocked by needing to write SQL. Do you remember this? Hopefully, yeah, great. So I made the point earlier that if your data are already in Snowflake, you might be better served by operating on Snowflake, because that's where the data are. But like, there's the obverse, yeah? What if you have a bunch of Parquet files on your local laptop? You don't want to start by like uploading 30 gigs of Parquet files to a Snowflake stage. That's not a good way to go about your data analysis task. That's a bad idea. But like, how do we do this? What if the local was the remote? Oh man, it didn't draw the last part. Anyway. Oh, we're gonna do things? Well, oh, that got ruined, that's fine. But the point is that you can do the same thing. Like previously I was saying like, yeah, this is Snowflake, that was a separate box, but this pattern still works. It's just now all on my laptop, right? If you want to use DuckDB or you want to use Polars or you want to use Data Fusion, those can run on your laptop. Same pattern. You just don't care as much about the fact that you're not, you know, shipping data over the wire, because now it's like your RAM. But you know, but the same pattern works. So yeah, there are these like blazing fast, usually called like OLAP query engines that can run on your laptop. They are orders of magnitude faster than pandas. And you can run your local analysis faster, and then if you do need to run it on some huge remote cluster, if you've done this with Ibis, you can do that without rewriting your whole query, which is nice. So let's try that. So we should start by, so I have a query here. It is too big, let's be real. I'll walk you through it. Don't worry about all the details, just because it's a lot of code. But this is a very real thing, right? This is not some like toy example. So Seth Larson was trying to track the rise of compiled dependencies in Python packages. And one way you can do that, and what's being done here, is there are data sets called PyPI, managed by PyPI that has a list of every single file that has ever been uploaded to the PyPI. Not like every single package, every single file. And you can grab that and you can start, like one way to track compiled dependencies would just be to sort of aggregate over that and search for certain kinds of file extensions that we would associate with compiled languages. So in this case, we're loading a Parquet file, we're grabbing some columns, we're looking for if the path, which is the file path, contains any things like assembly or C or C++ or CXX or header files or Rust or Fortran, some combination of Fortran plus numbers, or is Go. Right? And we're removing some things that are in site packages or in testing. We don't want to include those. That's not really what we're trying to do. And then we just want to aggregate over all of that, replace all of those many ways of spelling C++ and just say C++, and replace all the versions of Fortran to say Fortran. Right? Group by that, unique it, and then get us our thing. Right? So this is in pandas. This you can do this. This is running on like 22 million rows, I think, right now. So I'm going to start that. Actually, sorry, I lied. Now I'm going to start it. Main. Okay. So let's now look at the same thing in Ibis. And this looks probably pretty similar, right? I mean, it's not exactly the same, but we're doing the same thing. But I'll say up here, we're saying con ibis.duckdb connect, but then we're reading that Parquet file in, we're filtering, this is the same stuff, searching for all those different kinds of file extensions, removing these path locations we don't want to count, then doing the group by, the replacements, the aggregations, the drops, and whatever else, right? And we can run this. And we can say Tapulars. And that takes, what does it take? 2.73 seconds. How's Pandas doing? Nope, not yet, okay. So we could do that. We could, but actually here, I've heard polars is really cool. So what if instead we did this in polars? And I'll just change this to say polars.connect instead. That's the only change to that code. Oh, well, shouldn't do up arrow there. Expert to polars. Oh. Time that. That's pretty good, 1.75 seconds. How's Pandas doing? Oh, they got there. Okay, minute and 12 seconds. That's not bad. That's really not bad. Or you could say, I've heard a lot about data fusion. Right? So, up here, how do you use data fusion? I don't know. I just do this. And we'll do 2PyArrow here because data fusion is like an Arrow native project. In 2.83 seconds. Now, don't trust these are micro benchmarks, right? This is a small problem for these things. Like there's going to be some jitter. That's fine, right? But these things are fast, is what I'm saying, right? That's 22 million rows. We're uniquing across it. We're sorting. We're aggregating. And Pandas took like a minute and 12 seconds. So that's a pretty good speed up, yeah? The other thing, and this is the thing that genuinely gets me every time, I'm gonna have to make this really small so this shows up, and I apologize for that, but it's gonna be worth it, I promise. So before, I was showing you this on just one of those Parquet files, basically the most recent data, which is, actually, sorry, I didn't show you the results of any of those queries. It just gives you a list of how many languages have files, projects use a given language. I'll show it to you in a second. That's only on one of them, so it's got about 2 months of usage, 22 million rows. This is the full data set. This is the one that's that same code using the full data set. So it's exactly the same thing. I'm just not globbing and removing most of those Parquet files. I think it's 1.1 billion rows is how much is in here, right? And if I do that, before I hit enter, what I want you to look at is over in BTOP, and I know it's small, and I'm sorry, I'll put my mouse over here. Used memory, okay? So how much, look, I got a beefy laptop here, right? There's 20 logical cores, 64 gigs of RAM, nice, yeah, right? I can do stuff. Do I need all of that? It turns out, no, I do not, right? So look at that used memory there, 7.69 gigs. I'm about to load 1.1 billion rows, and then perform a unique and sort and aggregate over the entire thing, okay? Let's run that. And let's just look at the memory. 8.08? What we start at? I wasn't even paying attention to what I was saying. 7 point something? Right. So we're using, 2 gigs of RAM? Do you have 2 gigs of RAM on your laptop? I've got some great news for you. Yes, this is going to finish faster on my laptop because I do have 20 cores, and yes, they are all pegged at 100 right now because DuckDB is very, very good at this. But you can run this on a Raspberry Pi, I think, right? Because you can have enough memory. Because it'll take longer to finish, but it will finish. And that is kind of incredible. Because do you need to be able to do this in a minute? No, it's nice. But if you can do it in 5 or 10 minutes, that's fine. Do you want to spin up Snowflake infrastructure to do this? That's going to take, this is hard, right? Plus, I have these 30 gigs of Parquet files at rest on my laptop right now. It's going to take me a lot longer just to upload them somewhere else to do this, right? So you choose the tools that are good for your projects, but are also reflective of where, the data infrastructure, where things are. This is what the output looks like. So you can see, starting from 2005 to 2024, I didn't time that this time. It takes about a minute on my laptop. It'll work on your laptop as long as you have more than 2 gigs of RAM available. I think that is a manageable ask. Okay. So that stuff's awesome. Oh wait, downtime. Yeah, we did that. So takeaways here. DuckDB, Polars, and Data Fusion are all very fast when you are operating on local Parquet files, also local CSV files, but CSVs are a nightmare, don't use them. It's really easy to switch between them using Ibis, right? And could I run the same query on Snowflake or BigQuery? Absolutely. In this particular case, that's a terrible idea because the first step is uploading 30 gigs of Parquet files. If the data are already in BigQuery and Snowflake, you should absolutely use it there, right? That's the better thing. Do you want to write a bunch of different dialects of SQL? No, you don't. Do you have to? No, you don't, right? Before, with the IMDb data, it makes sense to run in Snowflake. This time, you should run in your local. It's about where your data are, what systems you're dealing with. And I don't have to change the interface I'm using, because Ibis supports all of these systems, right? And that's this is my pitch here, yeah. Some features I may not have mentioned. So input and output, right, for CSV files, don't use them though. Parquet, but you might have to. PyArrow streaming, Torch pandas polars, Arrow CStream, Dunder dataframe. We also have escape valves, so you can always talk directly to the engine if you need to. So if there's some hot new feature that we don't currently support, you can still use it. We're never going to stop you from using the tool more specifically if you know your tool. We're just going to help you if you don't. And also integration with other libraries. When I say integration here, I mean direct integration, like they know how to handle Ibis expressions, but also this entire time I've been showing you writing outputs to PyArrow or to polars or to pandas. Do you know any libraries that don't work with one of those three things that you would want to use? Like, no, so it doesn't matter. So some closing thoughts here, and then I've got time for questions and stuff, but SQL is not going anywhere, okay? It's gonna outlive all of us, and the engines are awesome. The engines are awesome. The interface is suboptimal, but you should use tools that let you interact with the engine of your choice and play nice with the software ecosystem that you work in. And if you need to work with multiple engines, or if you're thinking of checking out some of these, fast new engines, I would ask you to consider using Ibis, and you can kind of future-proof yourself in this way a little bit. You can try out a bunch of things, you can figure out what works for you, and you don't need to learn 7 new tools, you can learn 1, right? The other thing I'll just mention here that I don't have any slides about is just that data is sticky. Something like Andy Pavlou said a while back. Like, if you're at a large company, I guarantee you there's not like a single place where the data are, right? Right? There's decisions that were made 10 years ago, which means that data is there, and like all the columns are only like, it can only be 8 characters long or something. There's things that have happened, and you have to deal with the aftermath of that. You don't get to unwind this for free. So you're gonna have to work with multiple systems. You might as well have an interface that lets you work with multiple systems. So having said that, you can install Ibis Framework. The kind of default is DuckDB. If you just say Ibis Framework, you'll get DuckDB. But you can kind of fill in the word where backend is if you're using pip or UV. There's a million package managers. But this is what they call it. They're called PyPI. For any of these backends, and then we're all in CondaForge. I can do the party trick where I say all these really fast, but I think you can just read them too. That's okay. And then as for us, you can find us on the internets. Our docs page and homepage, GitHub. I guess we're still on the health site. Zulip chat is where we hang out with the developers and stuff. So if you have questions, Zulip is like Slack, it's just better and open source and written in Python, and it has a nice threading model, so you can actually get an answer to your question and see what's been resolved and stuff. Zulip's great. You should definitely check it out. I almost said former colleague, Philip Cloud's a great guy. Has a YouTube channel where periodically he does live streams of either debugging or just working with Ibis. Could be a fun way to see someone working with something who really knows their stuff. And then we apparently also have a LinkedIn page. I don't know what that's for. And is that it? Yeah. Those are my canned questions. All right, that's what I got. Thank you very much for coming.
So you showed a lot of very functional kind of chaining expressions.
Yeah.
If you're writing something and you want something that has intermediates, do those get automatically then chained so that they don't come to your laptop, or?
Yeah, actually, here I'll show you really quick. That's a great question. So, that's really now it's way too small, huh? Which one will we go to? Let's go here. So if you, when I was, let's see, I'm just gonna do examples.penguin and stuff there. So this is just some sample data that we will let you quickly use. So if you just say T right now, right, you just have this expression that's lazy and it's deferred out, I should say, deferred, nothing's gonna execute. Until you say to something, to Parquet, to polars, to pandas, whether it's like this, nothing gets executed. If though, because you want to do exploratory data analysis and you want to kind of see how things are happening as you go, you can turn on this interactive mode, which will make things not entirely eager, but just a little eager. So now if I do T, what it basically does, it runs, and well, the query here is select star from table, but then it does like a limit of 11. And so until like, if you're not doing any big sorts, you can kind of see how your query is being constructed. And then yes, like you are paying the network transfer price, like from Snowflake or BigQuery, but only for those 10 rows, right? And then if you know it's going to be big, you can, I mean, there's other things you can do, like if you're on Snowflake or BigQuery, for instance, we have a sample method, so you could like take like a 2% or a 1% sample of some huge data set, pull it down locally, work on it locally with DuckDB, get your query ready, and then burst it back up to the whole thing. Like that also works.
Great talk, thank you. You mentioned some of the questions at the beginning about like, normalization of days. Are they 0 indexed or 1 indexed, or like nulls? Do they go at the front or the end? How does Ibis approach those kinds of conventions? Does it do some kind of normalization? Is it up to the engine?
We do normalization. So it does a good, there's like 4 questions in there. So for things like convention around days of the week, we strive to do the Pythonic thing. So whatever Python does, if you're using like datetime, that's what Ibis is going to do. And when we will make the engines follow that convention by like subtracting one somewhere or adding one somewhere or doing that. We try to smooth out all of as many of the engine specific things as we can to kind of give you consistent results. We obviously can't do anything about floating point numbers. And also tell you that the thing that we just I'm gonna say we'll never do is smooth out the difference between which regular expression engines the engines themselves use. There is no magical regex transpiler project that I'm aware of, and so that's gonna remain specific. But other than that, yeah, we try to follow things that I think from like a Python data science, like PyData perspective and Python perspective are what you as Python users would expect. And we will make the engines do those things when it's in our power.
First of all, thanks for the talk, very interesting. I had a question in relation to the different SQL dialects that you mentioned. So as an example, and I think you alluded to it at the end, but we're using ClickHouse, for example, which has a lot of like functionality that they added over time.
Yeah.
Could you just kind of like give an example of how you would be able to execute those if they're not supported by
Absolutely,
Ibis?
yeah. So there's a bunch of ways you can do it. This is still using DuckDB, but just like it would apply, right?
Yeah.
So if I have some table T here, the first thing I can do is I can say just SQL, and I could say select species from, I think this table is called penguins. We'll see if this works. Yeah, I can do that. So this is executing that eager way, right? Because I have interactive mode turned on. But even though I just ran SQL there, I can actually from here still do. I can still use Ibis after this. Like I can chain on that still. Oh, sorry, that's not a column. Species.lower. Still works, right? So you can drop into SQL and then come back to Ibis. If like you know how to spell something in SQL, you want to use it, you can just do that. The other thing you can do, ClickHouse is very function heavy. Like there's a function for everything. We have a thing where you do, thank you, tab completion. Where if you do, sorry, that's probably really too low down here. You can say Ibis UDF scalar built in like this, and you can say def, my ClickHouse func. That takes, some, and like what's the function signature? It takes some X and it gives back like an int, yeah? If you define that like that, an empty function body, but the name of the function matches the ClickHouse function, you can use this in Ibis and we'll just pass that through directly to the underlying engine, right? So you can define, you basically give us a clue about the name of the function you want to use, and you can just use it transparently on Ibis.
So I can then still chain it.
Absolutely, yeah.
Thanks.
In the previous example where you have pulled in those 10 rows and then add in Ibis after, is this running on those 10 rows, or when does it go and like pull in more data?
So that's a great question. So when I do this, what happens is, actually what I'll do is I'll turn off interactive mode and I can show you that. This is what's happening, right? We have like the table, and this is, I know, not like the most readable thing, this is mostly for developers, but like there's this table and the SQL string view, because we know what we want to do is run that like inline SQL and then do something else. When you're in interactive mode and you're getting this kind of like nice, snappy, I want to see what's happening thing, all that we're ever doing, we're executing the query, and then we're saying, give us the first 11, well, we'll say the first 10 rows. It's actually 11, so we know if we need to put a dot, dot, dot there if there are more than 10 rows. But we are pulling in only as much data as we need to execute that like small portion to show you the preview. There are operations like if you sort the entire data set, the engine needs to do all of that work before it can show you what the first 10 will be. But the only thing that's going to come over the wire from like a remote engine are those 10 rows.
So I have a question about the SQL that you're showing.
Yeah.
Is that still decoupled from the execution engine? So like, can I write Ibis SQL and have it run against whatever Postgres backend, etc.?
Yeah. So I should note this is thanks to the magic that is SQLbot. So thank you, Toby Mao and Toby Go for that. I wrote DuckDB. Sorry, this is also a select column from table that genuinely does work across any SQL dialect. Probably. Philip may know better. Anyway. But yeah, if I were writing this, let's say I'm writing DuckDB SQL because I know I'm running against DuckDB. But if I know DuckDB SQL and I'm actually running against Postgres, well, bad example, and I'm running against Snowflake, also bad example. ClickHouse, very different. I can just pass dialect here. And that will translate the SQL that I write into that dialect. Or is it? Yeah, I think that's right, yeah. In this case, that also works on DuckDB because again, this SQL is pretty straightforward. But yeah, we will let you, if you know SQL, but you don't know the dialect you're writing in, we'll let you use that in line and just transpile it to the appropriate dialect for you. I mean, so you have to tell us what the target is, but like, we'll do that for you. Yes? No, sir.
Is it best if we hold off the questions because we are already out of time?
Oh, we're out of time. All right.
We have to get ready for the next presentation.
Okay.
But you'll be around, right?
I'll be around in the hallway. I have stickers. You should come find me in the hallway if you want stickers.
You can always ask questions.
I remember. Great. And yeah, please come find me and ask questions. I'm happy to chat.
Wonderful presentation. Thank you so much for coming.